Hi, good morning students. So continuation topic is the formation of PN junction diode. Now we will discuss about that topic. Okay. So this is the formation of PN junction diode. Here this is a P-type semiconductor and this is N-type semiconductor. This totally becomes PN junction diode. So the hole, here it is the hole represents hole and this black end, this represents electron. During the junction formation, the free electrons, these are all free electrons, they are present in the N-type semiconductor. These are all holes, they are present in the P-type semiconductor. Here, the electrons, free electrons in the N region are migrate towards the P region, and the holes in the P region are migrate towards the N region. This process is said to be diffusion. This process is said to be diffusion. This process is said to be diffusion. Once again, listen carefully. What is a diffusion? Means during the junction formation, the free electrons in the N region are migrate towards the P region, and the holes in the P region are migrate towards the N region. This process is known as diffusion. During the diffusion, negative ions are left over the P region. Negative ions are left over the P region and positive ions are left over the N region. Left over the N region. And these ions are immobile. These negative ions and these positive ions are immobile, and they can build up an internal electric field which is directed from N-type to P-type. There is a difference, there is a potential difference at the junction, that is called barrier potential. Barrier potential. Here at the junction, near the junction on either sides, the holes and electrons are recombined with each other and they become neutral. Here it is at the junction, near the junction on either sides, electrons and holes, what happens? They become neutral. Here it is, a narrow region is formed which is free from mobile charge carriers, is known as depletion layer. A narrow region is formed between P-type and N-type semiconductors where there is no mobile charge carriers. Is called depletion layer. This is a depletion layer D. D means it's a depletion layer. A depletion layer. What is a depletion layer? A narrow region is formed. Why the narrow region is formed here? Either sides of the junction, the holes and electrons are migrate with each other and they become neutral. A chargeless region is formed between P-type and N-type semiconductors where there is no mobile charge carriers, is called depletion layer. Here it is a depletion layer. What is a depletion layer? Again, we will discuss about this definition. What is a depletion layer? A narrow region. This is a narrow region. This narrow region is formed between P-type and N-type semiconductors where there is no mobile charge carriers. There is no mobile charge carriers is called depletion layer. For the current conduction, the width of the depletion layer should be decreased. What happens if the depletion layer formed? A depletion layer sufficiently built up here, it prevents the further flow of holes into the N region and electrons into the P region. It acts as a barrier so that it prevents the further flow of holes into the N region and electrons into the P region. So that the width of the depletion layer should be decreased for the current conduction. Got it? Right. Next, what is a biasing? Next topic is biasing. A proper current connections should be given to a diode. Is said to be bias or biasing. Biasing are of two types. Biasing. First one is a forward bias. First one is a forward bias. Second one is a reverse bias. Reverse bias. Forward bias and reverse bias. What is a forward bias and what is a reverse bias? Look at here. Now we will discuss about the forward bias, and here it is we discuss about the reverse bias. Suppose if you take a diode, this is P type and this is N type. This is the symbol for battery. The big line